Hello there. I am Dumitru Pascu from Mindit.io. Welcome to our webinar AI Sandwich, from long-term AI strategy canvas to quick wins with RAG. Today, we have the great pleasure of having at this webinar our friends from Amidiro, represented by Tobias Haustein. Tobias is a seasoned tech executive and front-runner in AI and digital transformation with over 25 years of experience. His journey in technology began with a fascination for its potential to revolutionize industries, and today he is dedicating to integrating AI into business strategies, leading companies towards digital excellence. Our colleagues from Amidiro have developed a framework to define and visualize the AI strategy of your company called AI Strategy Canvas. Tobias will present you this AI strategy framework, and later we will also show you how to address quick wins with the Retrieval Augmented Generation, RAG, and of course a demo. So, without further ado, I invite Tobias to tell us more about this. Welcome, Tobias.
Good morning, everyone. Thank you, Dumi, for having me. So I'm going to share my screen. Give me a second. And then I'd like to talk about how to develop an AI strategy. So if you are a business and want to develop a strategy for dealing with AI, the question is, how do you get started? But before you get started, the first question is, why? Why would you start using AI? How is AI actually important? And let's have a look in how AI has been developed over the last decades. So you all know AI is nothing new. It has been invented more than 70 years ago now. So it's been a while that people have been talking about AI. But only recently, AI has changed its pace. So whilst it took decades to get AI do anything useful, in the last 20 years or so, we see that the new approach of machine learning, and especially deep learning, leads to tremendous results. So on this chart, we see how AI tools or AI models have developed in regards to specific tasks. And for example, it took between 13 and 17 years for deep learning-based AI models to become proficient in handwriting recognition or speech recognition. So nowadays, these models not only reach human performance, which is indicated as 100% on this chart, but they even surpass what humans can do. So machines are actually better at recognition of recognizing handwriting or recognizing speech than a typical human is. But in the last years, the pace at which such tasks could be solved by AI has changed dramatically. So with the most recent models, once people started investigating how to tackle a specific problem, it turned out that machines could achieve human-level performance or near human-level performance within mere months instead of years or even decades. And if you contrast this with how humans evolve or how the humans' capabilities evolve in business, you see that in the European Union, the statistics from Eurostat clearly show that you only have on average 1% of productivity gain per year. So essentially, we are developing, but we are developing very, very slowly. And this is more or less a constant factor over 20 or 25 years. If you contrast this with what productivity gain businesses can achieve when they introduce AI, you see that they really leapfrog. So there are now published numbers from various businesses, from various sources. These numbers are from McKinsey, PwC, and GitHub. And they claim that within customer services, the usage of AI can boost your efficiency by 15% on average. In legal services, where you have to read a lot of documents and compare documents. How have they changed? What has been changed, and does it apply? AI can now take over large parts of regular processes, leading to an efficiency gain of roughly 25%. And in software development, we see that the efficiency gains that can be achieved are even greater. And some companies claim that they more or less halve their development effort. This is very important, or it's very important to note that these efficiency gains also lead to higher quality. So essentially, especially in software development, we see that the best software developers do not benefit so much from these tools, but the less skilled software developers have tremendous success by using these AI tools, because the tools really help them getting more and better work done. So we see AI can boost productivity, and it can also increase quality. But on the other hand, there is more that you can expect from using AI. So one example is how Spotify used AI to drive hyper-personalization. So if you have intelligence available more or less for free, then you can use this intelligence to craft new products or craft new capabilities within your products that delight customers. And this tweet summarizes very well. It says that essentially the AI of Spotify knows what people would like to hear, and it knows it even better than the people probably by themselves. And what did Spotify achieve with this AI introduction? Well, actually, they bet the big four, or the big players in the market. Typically, as a startup, you don't want to compete with Google, Amazon, and Apple. But Spotify not only picked up the fight, but really outclassed these big players. And this is mainly due to AI. Obviously, AI is not everything. You need to be very good in your business anyway. But AI is considered to be the secret sauce which made Spotify the dominant player in the music business. So the first lesson for my talk is that AI is really developing at an unprecedented speed. So it is really developing extremely fast, and you cannot predict how it develops, but it is important to monitor the development and really understand what's going on. And in such an environment, it is very difficult to secure a competitive edge against competitors who use AI. But if you do not use AI, it is very easy to fall behind, and this will pose a significant risk on your business. So this answers the question why you would craft an AI strategy. But now the question is, how do you do it? First, you have to define your ambition level. So there are 5 levels of AI adoption, and you have to define for your business how far you would like to go. The first level are AI non-users. These are people or businesses who don't see a benefit of using AI, and they don't want to use it. The second level are AI consumers. These are businesses who utilize AI as it is being provided by their standard tool vendors. Like they use Copilot as it now is rolled out by Microsoft, but they don't really invest heavily into AI. The next level are AI automators, level 3. And these businesses embrace AI. They build customized AI automation solutions. They engage in AI development, and they mix self-developed tools or software with ready-made AI technology. The fourth level are AI builders. They develop complete new solutions based on AI. They customize AI heavily, and they try to innovate by using AI. So these businesses not only try to be more efficient, but instead they try to be innovative or innovators in the market. And the last level are AI researchers who pioneer in AI research, who invent new types of AI, and who lead the advancements in AI technology as such. Most businesses today are on level 1 or probably on level 2. And most businesses will probably never reach level 5, because this is something where you have to be heavily committed in being an AI pioneer. But essentially, we expect that a large portion of businesses have to become proficient in AI and should achieve level 3 or level 4, depending on their strength, on their market position, and on their ambition. So if you now want to achieve a higher level of AI adoption, the question is, how can you do it? And there are multiple simple decisions that you have to make. If you strive to adopt level 2, you can simply use ready-made tools. And everyone who once has used ChatGPT knows what the prompt is. So you prompt the AI to do what you wanted it to do. You have to learn how to use the AI, how to do it. But this is called prompt engineering. It's the most basic and easiest way to interact with an AI. If you strive to achieve level 3, then you need to look into tailored software. And the first and easiest approach is to use ready-made models. So AI models that are provided by vendors that are ready to use either via API or which are provided for self-hosting and use, for example, on premises or even in your own cloud. There are tons of ready-made models, and more models come out every week. So this is really a great way to get started with using AI in more specific processes. And the next and most difficult approach, but also the most rewarding approach, is that you tailor the models to your specific needs by fine-tuning them or by training your own AI models. But of course, this comes at a cost. The effort that is needed to tailor models is way higher than it is needed to just get started with ready-made models. Now, in order to structure your strategy, you have to define several aspects of your overall strategy. And we believe that you really need an AI strategy in order to get benefit from AI. Of course, you can just start with some individual use cases, but this is only to raise awareness. It is to understand what the technology is able to do and where you could probably benefit from it. But in order to really make a change or a meaningful impact on your business, you have to have a strategy that is well aligned with your business strategy as a whole. And we define the following aspects that you have to tackle. First, you have to set the foundations. We talk of 3 foundations. You need to have awareness what AI is and what it can do. You have to acquire the talent or build up the talent that is needed in order to use this technology. And very importantly, you have to define strict governance. Everyone is now talking about ethical use of AI because people fear that AI can be misused, and therefore it is important to set up strict governance. But these are only the foundations. In order to really benefit from AI, to leverage it, you need drivers. And these drivers are technology and data. You have to check which technologies you currently have in your business. And most businesses have to invest in their technology in order to really benefit from the use of AI, because only then you can leverage its full potential. But AI is nothing without data. So, of course, you can simply buy ready-made AI models and AI solutions, but then your business will not be better at what you do than any other competitor who uses the same technology. In order to differentiate in the market, you need to provide your own data. And we come to that again on the next slide. But then we talk about strategic pillars, and the strategic pillars give direction. So with having the foundations and having drivers, you still need to decide where to go. And there we differentiate three pillars. First is everyday AI, the second is game-changing AI, and the last one is cover your back. And let's see on the next slide what this is all about. So everyday AI is how to use AI to leverage or to improve your existing processes. So you know how to do business. You've got existing processes, and everyday AI tries to improve the efficiency of these processes or the capabilities that you currently have by using AI. So it's about efficiency, it's about innovation in the small, it's about expanded capabilities. And in the end, it's about being competitive. So with everyday AI, you just stay ahead of the crowd and you make sure that you do not fall behind when your competitors achieve the performance benefits of AI, that you can still compete. More interesting are game-changing AI. So this is about transformation. It's about defining a new way of doing business and disrupting the market, or probably fighting beyond size. So with game-changing AI, you compete, or you can compete against new or can enter new markets, or you can outcompete existing players in the market, like Spotify has done against the big techs. So this is fighting beyond size. A small company can really fight against the big players in the market by using AI to scale its business and to scale capabilities. But if everyday AI and game-changing AI becomes prevalent, if other players in the market adopt AI, there's a risk that you are going to fall behind. And therefore, the third strategic pillar is cover your back. You have to make sure that you stay in business even though the market changes fundamentally. So you have to be prepared for market shifts. You have to future-proof your business. You have probably to forge alliances with others in order to prohibit others from entering into your market. And you should define rapid response measures. So if you see that a competitor is successful with AI, that you know how to counteract these developments. Regarding technology and data, it is important that you do a thorough analysis where you stand right now, which technologies do you have in your businesses, how do we have to improve these technologies in order to be able to use AI effectively. On the other hand, regarding data, it is very important that you first identify which quality of data do you have, which data do you have, which makes up your business. So when you hire new people, these people know nothing about your business, and you have to train them in order to fully get the potential of these people for your business. And it is comparable with AI. If you now have new AI systems which you adopt for your needs, then you have to train them. And this training is being done with your data. So you have to collect data, you have to make it accessible. You probably have to seek partnerships in order to get more relevant data, and probably to secure your data, for example, by agreeing in or going into exclusive partnerships with data vendors, if possible. And this leads to starting to think in ecosystems. Instead of relying only on the data that you have in-house, you have to think about which partners do you have to work with in order to build an ecosystem which gives you the competitive edge. So this is, in short, the Amadiro AI strategy canvas. And actually, it is meant to be printed out on paper and filled out in a workshop or multiple workshops. And actually, there is much more behind it. So there is a whole process with many individual artifacts which are being used to fill the canvas in order to come up with one integrated AI strategy in the end. So that's the second lesson for my today's talk. Businesses should define their strategic goals first, then build the foundations, and followed by the drivers to get there to really achieve AI proficiency in a structured and strategic way. Thank you very much.
Thank you very much, Tobias. That was an insightful presentation. And for me, I loved especially the part where you defined the 5 stages of adoption when it comes to AI, from non-users to researchers. And I think that it is very important for the organizations to be honest with themselves and especially when they are performing the initial assessment, as well as when they define the stage that they are targeting. And I will thank you very much again. I will try to share my screen and start with the concrete use case and the quick wins with the retrieval augmented generation. One moment, please. Yeah, do you see my screen? Yeah. So basically, we'll discuss about the concrete use case, a quick win, because retrieval augmented generation, RAG, is nowadays a very popular method among developers. RAG combines the usage of large language models with retrieval from a knowledge base, so that in the end, the large language model provides information by using the one from the information from the knowledge base. How it works? So it initially, as you can see in the image on the right side, initially we take the documents that we want to use in our knowledge base, and these documents are chunked in very small pieces, and then these smaller chunks are passed to an embedding model, and we will describe a little bit later what an embedding model is. The result of this processing, the embeddings, are stored in a vector database. Again, we will present a little bit later what a vector database is. Now, at step number 3, let's assume that we have a user that says, create a quiz with 10 questions based on XYZ data. Then this query is processed through the same embedding model that we used at step number 2, and the embeddings for this query are generated. Now, the vectorized prompt, the embeddings that we generated based on the query are passed to the chat application, and the chat application passes the vectorized input to the vector database. And the vector database returns the closest pieces of content based on embedding similarity search. At step number 7, the chat appends these chunks to the original prompt created by the user. And at 8, the large language model generates the output based on the prompt and the original chunks that were used to append to the prompt. And of course, the user is happy because the result is presented to the user. Now, as I said, a few words about the vector databases, because they are an important piece of this solution. And actually, the main difference between a traditional database, and when I talk about traditional database, I refer to a relational one and a non-relational one. So we have SQL and NoSQL on the other side as traditional databases. And now let's refer to these vector databases that store embeddings, which embeddings are high-dimensional data representations. More simply explained, these vector databases are optimized for storing nothing more than array of numbers that represent features associated with the data and not the data itself, as in the case of traditional databases. So this is the main difference. And since AI models work with numbers, these databases are suitable for AI applications and are ideal for recommendation systems, image recognition, and natural language processing. Now, let's pay attention to these vectors that are stored in these vector databases. These are the embeddings. Why are they important? Because they measure the relatedness in terms of meaning for the text strings. And according to a resource from the OpenAI documentation, they are used for search, and this is the use case that you will see today, where results are ranked by relevance to a query string, for clustering, where the text strings are grouped by similarity, recommendations, where items with related text strings are recommended, for anomaly detection, where the outliers with little relatedness are identified, for diversity measurement, where similarity distribution are being analyzed, and for classification, where basically the text strings are classified with their most similar labels. And now we worked on this concrete example so that we understand at a high level better how these embeddings work. As you can see on the slide in the left side, an embedding is nothing more than an array where each element represents a feature. We don't know exactly what this feature has, but we know the number of features that each model produces. These values typically have values between -1 and 1. Now, on the right side, you will see a graphical representation of three features that we cherry-picked from the output of the open source model for the following words: king, queen, prince, princess, man, woman, boy, and girl. And the features that we cherry-picked might suggest royalty, gender, and the last one, if the term is associated with an adult or not. We called it adulthood, but we could call it age as well. So let's look at the first column, where we assume that we have the royalty feature. We will observe that the hotter values, the ones that are closer to 1, are represented by the king, queen, prince, and princess. We can assume that these are the royals, whereas man, woman, boy, and girl are on the cold values, the cold value spectrum, closer to -1. So these could be the commoners. Similarly, let's have a look at the second column, the gender column. Hot values, closer to 1, are represented by the king, the prince, the man, and the boy. These represent the male genders, whereas the cold values closer to -1 are represented by queen, princess, woman, and girl, a female gender. So, and last column, the adulthood, is a little bit more interesting for me. And we will see the king, queen, man, and woman in the hot area, the adults, while the others are in the cold area. But what we see is that the king is very close to 1. And I would speculate that in the text used to train the Glove embeddings for the words, the king was an older person most of the time. Therefore, that strong red color corresponding to 092. Now, let's understand a little bit how classical word search is different from embedding-based word search. Classical word search look for exact similar words or phrases in the text stored in the database, while the embeddings-based search understand the meaning of the words to find related concepts, not just exact matches. Classical word search require exact spelling and may miss relevant results, while embedding-based search captures synonyms, related terms, but could be totally different words. So in terms of business impact, keywords-based search are definitely faster, are straightforward, and they are very good, of course, when you want to perform exact term search, while the embedding-based search will increase the user engagement and will provide more relevant and comprehensive results, thus improving user satisfaction when it comes to search by meaning. Let's take an example. If we search by budget travel tips, the classical search will return content that contain those exact terms, while the embeddings-based search will also return content that contains affordable vacation advice, which for us humans is kind of natural, and we would expect this kind of results. And now, because these embeddings influence a lot of the accuracy of the response, but also they have a big influence on the cost of your solution, we will talk a little bit on a strategy to select these embeddings. First, of course, you have to identify your use case, but then you have to think about the volume of data. So if your volume of data is very small, then our recommendation is usually to go with OpenAI. Other embeddings are easy to use, the API easy to access. So I don't think that it's worth the effort in pursuing other things. But when the volume of data becomes large, things complicated. So our advice is that you consult the Hugging Face MTEB leaderboard, and you should consider the application type, be it for search, classification, anomaly detection, and so on. And always, this will impact the dimension of your vector database. Check the output dimension of the embedding models. They will heavily impact the storage costs. Also, use this leaderboard to evaluate the performance requirements, and depending on this, decide whether you go on-prem on cloud. Consider the accuracy. You can do your own test, but MTEB leaderboard contains a lot of parameters for benchmarks. You could start for there. And last but not least, you have to estimate the long-term cost versus the performance, because they will influence a lot this cost. So this is basically the thought process where you select the embeddings. Now, with the large language model, again, there are multiple situations that influence the selection. Of course, one of them is accuracy. Do you need high precision? Do you need moderate precision? Of course, larger models are more accurate, but usually more expensive. Then again, you have to take into consideration the inference speed. Larger models tend to be slower, while smaller distilled models infer faster. Privacy, secrecy of data is another thing that you need to take into consideration. In our opinion, if you use cloud for your daily business operations, then you should consider cloud for deploying your AI solution as well. Otherwise, go on-prem. For the scalability, larger is more expensive, and you can always use the calculator, the model memory calculator from the Hugging Face to calculate the amount of VRAM, thus GPUs that you need. Nowadays, compute availability is also a problem. So, and if you need the flexibility, then we recommend to stick to PaaS. You need to consider the use case, the content generation classification, because the models perform different depending on the use case, and also many situations where you need custom models for healthcare and finance, but you can decide to use general knowledge as well. And last but not least, you have to put budget constraints in order to limit the costs. Yeah, so you have to consider them as well. And now a short recap of the cost considerations. So basically, you always have to consider the volume of data. You also have to consider the embeddings, how you ingest the data, how you compute the embeddings, where do you store the embeddings. the vector database that we have discussed earlier, the accuracy of the retrieval, the decision on what the LLM you use and where do you host it. And also another thing that we didn't mention so far is the prompt input, because this will influence the cost. And when you think of RAG solution, you have to consider the average chunk size and the max number of chunks per prompt. And in the table below, you can see some standard parameters that we used when we estimate the cost for the custom RAG solutions that we create here at Mindit.io. We consider documents per month, average document size. We usually consider tokens because usually we are charged by tokens, number of users per day, average queries per user per day, and therefore it's easy to calculate the total queries per month, the chunk size in tokens, the number of chunks per prompt, average prompt input, and average prompt output. We use average prompt input separated from average prompt output because they are charged in a different manner. And now, let's go to the last slide of this presentation before our demo, where to host this. So we put three main criteria. Of course, there are many, it always has many facets, but to start with, if you have low data volumes, decisions are a little bit simpler because our recommendations to go with general available embedders that require less effort to deploy like ADA. And the storage retrievers, I would argue that any would suffice. For instance, if you use open AI search from Azure. There are free tiers there and even basic tiers, which are very, very cost effective. And I would recommend to go with that. And also for the large language model, I would recommend to use the wide selection of models available on Azure AI and AWS. When you have a high volume of data, you have to test different cloud providers. And for embedders, there's always the possibility of using Hugging Face models, both cloud and on-prem. You can use their inference APIs, but you can use them on premise as well. And of course, as I said, if you use for your business daily business operations cloud, I would suggest that you start with Azure and AWS as well. On the storage and the retriever side, it depends on the output of the document model and the number of concurrent users. But at least this is relatively easy to estimate because the output of the model is fixed. And if you know the volume of data and the number of concurrent users, the number of search, you can calculate the storage and the compute that you need. And for the large language model, consider Azure AI, AWS, but also private cloud provider. Here you have to calculate the VRAM required, thus the GPUs that you need to deploy your models, consider the concurrent users, completed queries, and time to first token. Now, if there are privacy concerns, and if you must stick with on-prem, then using models from Hugging Face where you can deploy them as well on-prem. But if you use cloud provider, use it by no means. Again, the storage retrieval, the same. You can easily. There are formulas to calculate them, and for the large language models, use Hugging Face model or OpenAI, Azure, and AWS. Now, we will have now a demo where this demo we used the solution accelerator for RAG provided by Microsoft. In this solution, what we did, we took a big PDF of 600 pages for a Volvo car user manual. For me, for instance, when I buy, whenever I buy once many years, and I have a new car, I usually spend around the day studying that user manual, which is very verbose. And it would be great for me to have a RAG solution that would chunk that document and provide me information about this. So let me show you this RAG solution. You see it? Okay, perfect. So as you can see here, I will start with any question. For instance, we prepared some questions. How do I start my car? Okay. So it starts generating the message. Seems like a legit indication on how to start your car. But what's very interesting, and this is the fact that it provides a citation. And if you have a look here, it took a little bit to load this because as you can see, it's 643 pages, and you'll see it guided me directly to the section where the car is starting and driving. And also, what's very interesting to see, I want you to show you the thought process. And here we have the question that the user asks, which is, how do I start the car? And then you can see the system prompt that we configured for this AI agent. You are an intelligent assistant helping Volvo customer with their questions from their car user manual. Be brief in your answer. Answer only with the facts listed in the list in the sources below. If there isn't enough information, say you don't know. And we also instructed it how to respond so that we have a correct citation here. And below you can see the sources that we sent, the chunks that we have sent to the large language model. And in a more nicely manner, you see the exact chunks that were the chunks that we found during the search based on this. And yeah, these are the sections that were used by the large language model to provide the answer. Of course, this is just a solution. And by the way, I see a question from our chat. How would you define low data volume and high volume of data? If there is a threshold, well, for me, low data volume, this kind of PDF would be a low data volume. For instance, I would say that whatever is below, I don't know, a few hundred megabytes of data for me would be a low data volumes. After that, I would have to test a little bit and see how different vector databases and embedding models work. And yeah, this was kind of all. This was our presentation. Thank you for attending to this webinar. And from now on, we will be taking a few of the questions. My colleague will prepare the questions. So I have a question. Can we access your demo, please? We have to play ourselves. Of course, we will provide the link. The link is generally available, so you can play with it. Yeah, and you can see how it works and how the LLM resonates. And we have another question. What future developments do you anticipate in the field of retrieval augmented generation? Very interesting question. Tobias, would you like to answer to this?
Sure. Well, RAG will surely be relevant for the long term. So there are developments underway that LLMs will probably have the capability of changing their knowledge once they are in production. So we see similar developments in image generation, for example, that you can have so-called LoRa adapters in order to provide additional information to a pre-trained model. And similar techniques are currently being developed for LLMs. But essentially, a RAG system is much simpler and much easier to use. And therefore, both approaches will probably be used in combination. And the problem right now is that RAG systems are difficult to get right, especially if you have large volumes of data. And this has to do with the context length that you can use and with the question, how can you make sure that the embeddings actually fit the intent and not just the obvious information that is present? Like, for example, if you do not have a simple question like, how does the current get started? This can be looked up immediately from the manual. But if you have a more complex question which requires reasoning or things like so, then it becomes more difficult. And there are techniques which are underway to combine the reasoning capabilities of LLMs with RAG. And some of these mechanisms are multi-turn RAG, so that you do not just use one RAG once, but instead use multiple turns. But there are also other techniques. With larger LLMs or better LLMs, we'll see that some of the technologies that are used nowadays will become obsolete. So, for example, right now, the context size of LLMs is quite small. But as the context length gets longer, we do not have to chunk the input so much. So nowadays, we often use sentences or paragraphs and chunk these so that, on the other hand, the LLM does not see how things relate to each other, but it only gets a small piece. And if the context length of the LLM is bigger, then we can have larger chunks or even full documents which are going into these embeddings, and then the capabilities will increase. So these are some of the developments which are currently underway.
Yeah. Thank you, Tobias, for this. I also wondered a lot in the past period whether the RAG systems will become obsolete with this increasing context window that we expect for the new large language model that are about to come. And I agree with you that RAG will probably not become obsolete, but instead we will increase the chunk size that we store in the vector database. And also for me, something that will be very interesting, and I already see it coming, is multimodal RAG. What I understand by multimodal RAG is that storing into the vector database multiple types of content, not only documents, but also video, images, audio, and documents, Word, PDFs, whatever, so that you serve them into chat-like or whatever other type of applications in the proper way for serving that content. And I'm quite excited about the prospect of this development, and I see it coming because I see a lot of embeddings being focused on various type of content. So by mixing them in a more complex RAG solution, I see this kind of, and I'm looking forward to seeing this kind of solutions. Yeah.
Yeah, this also relates to the question that has been just asked, whether you should build a RAG application in-house or use a ready-made solution. So if you need more or less a standard solution, then you can go for a standard offering. But if you want to build something very specifically, and as Dumi just said, for example, combining multiple modalities, or have an LLM which has special reasoning capabilities because it understands what is actually talking about, then building a RAG system in-house is very much preferred. So I would like to give one example. NVIDIA has built a very sophisticated internal system which combines RAG with fine-tuned LLMs. And these fine-tuned LLMs, for example, know the specific languages which are being used by NVIDIA to describe their GPUs. And this is combined with the RAG system, which has access to all the design documents of GPUs. And they use this system internally to make their engineers more productive. So this combination of multiple sources with fine-tuned LLMs and specific agents which are built on top of this. This is a very complex system, which is not so easy to build, but this by far outperforms everything that you can get from any vendor or ready-made solution. So if you want to get started, it's best to get started with a ready-made solution. And there are now many providers, and also, for example, Microsoft or AWS and NVIDIA and so on are providing ready-made RAG systems now, which can be easily adopted. But then if you want to build more specific processes around it or give it more capabilities, you can build your own RAG system.
Yeah, thank you. I think we also have another question. How does the choice of the retrieval database impact the performance and reliability of RAG system? If I may, I will start answering to this question. So basically, if you remember I think it was the first slide in our presentation. After at step number 3, if I remember well, when the customer or the user asks a question, then at that step, the first thing is that the query is passed to the retrieval database, and the similarity query between your query embedding versus embeddings that are in the database is performed. Well, if that query takes a long amount of time, obviously that will add to the total time of response that will be perceived by the end user. So I think it's crucial that you do a correct dimensioning of the vector database, so that once it's cost effective from the point of view of storage, and two, it responds you in the amount of time that a user would expect for this. If you would have 5 seconds just to perform a query, then these 5 seconds will add to the LLM generation output prompt and so on. So yeah, it's crucial, I would say. Yeah.
Probably it's worth adding there are specialized vector databases which are very good, but astonishingly also existing databases like PostgreSQL are now being expanded by vector search capabilities. And I've seen an example of a huge customer who used PostgreSQL as a single database for the application, and they were very successful with using the vector database extensions of PostgreSQL. So you really have to look into which stack you already have in-house and which suits your needs. These vector databases are outstanding, but you do not need them in every case. There are cases where you can still use what you already have in-house.
Tobias, are you referring to the PostgreSQL database?
PostgreSQL supports as a vector database extension.
Yeah. Because I already we played a little bit with a database PostgreSQL that you can basically, and it's very interesting, you can run or execute large language model prompts with the SQL queries. a very nice way of creating a very simple architecture with that database. So check it out, PostgreSML. I love that product. Yeah. So I see there are no other questions. So Tobias, I want to thank you for your participation to our webinar. I hope you enjoyed it, and I hope our audience enjoyed it. And by the way, if you want to discuss more about this and discuss about custom RAG solutions, we at Mindit.io create such solutions. So we would be glad to understand more about your use case and help you with this if we can. Okay. Until then, keep growing, keep learning. Bye-bye. See you later.
Thank you. Bye-bye.